Hi, good evening. I am Nur Nadia Zati binti Zamri, CF210212, and I would like to present about the background of this project. So, a project of composing and resolution of this issue that involve the appliance of numerical method involving applied science downside is being proposed. The aim of the project is to spot the extent of understanding the scholars that have for this course and eventually we relate the strategy learned in real life. In this project, we use Simpson's rule 1/3 as the application of numerical method in civil engineering.
Hi, my name is Nur Agnia binti Muhammad Nazlin and my metric number is CF210324. I would like to present about introduction of Simpson's rule. Simpson's rule is named after Thomas Simpson in 1710 until 1761, who published it in 1743, and it is used for estimating definite integrals. Simpson rules could be a numerical integration methodology. The numerical approximation of definite integrals is known as numerical integration. In fact, this method is an extension of a trapezoidal rule, which uses a second-order polynomial to approximate the integrand. Simpson's rule provides a good approximation for the area under a curve. This rule uses parabolas to approximate a portion of the curve. When compared to the opposite numerical strategies, this method is more efficient because it is more accurate. Wherever n is even, this method uses approximation for equally spaced subdivisions. Next is problem statement. The problem statement is to determine how many cartons the engineer should purchase to cover such a surface, adding 10% for safety. Simpson's method was used because the pool's shape is curved, so Simpson's rule will produce more accurate results. Next is objective. Firstly, to review journal and thesis related to the numerical method. Secondly, to determine the number of cartons the engineer should buy to cover the surface of the swimming pool. And third, to apply the numerical method of solving the numerical integration by using Simpson's method.
Okay, so now I will continue this presentation to talk about the literature review. So as we know that ground pools can come in any number of shape. The shape includes the rectangular shape, round pool, kidney shaped pool or any custom shape chosen by the pool owner. There are many methods and formulas that can use to determine the area of irregularly shaped curve such as Simpson's rule and trapezoidal rule. But in this project, we use Simpson's rule 1/3 as the solution to the numerical method to calculate the area of the pool, and we will get the how many carton that we need to fulfill the calculation.
Next is filler table. First column is about the facts, second column is the ideas, third column is learning issues, and the last column is the actions.
My name is Feng Ziyi. Let me to continue to the methodology and the calculation part. Figures show the relative parameter of the length from the edge of the pool. In this project, the method of Simpson's 1/3 rule is used to calculate the relative area. The formula of Simpson's 1/3 rule is Fx equal h/3 blanket F0 plus Fm plus 4 times the odd numbers plus 2 multiply the even number of F1, Fi. Or we can use the other formula of the Simpson's 1/3 rule, which is Fx equal to h/3 times area A1, A2, and A3. To determine the relative area of pool A. There are 3 parts of area where we calculate, which is A1, A2, A3. Area of upper part. A1 means the area of the upper part of the land from the edge of pool. A2 is the area of the lower part of the land from edge of pool. A3 is the total area of the lands and the pool. Here is the drawing of the pool. Let me go through to the calculation parts. First, we need to calculate the area of upper of land from the edge of pool A1. First, we need to find the hash. Hash equal to B minus A over N. From the drawing, we can get the B is equal to 138, A equal to 0, N equal to 10. Then we get the hash is 13.8. Then we can use the hash and put inside the calculator and get the answer for A1 equal to 5,825.7160 meters square by using the Simpson's 1/3 rules formula to get the answer. Then the next part present by my group member, which is Miza.
Okay, Assalamualaikum warahmatullahi wabarakatuh and very good evening. So my name is Nur Hamiza binti Hafiz and my magic number is 210308. So we go to the area of the lower part of land edge of a pool, which is the A2. So the first step we have to find the value of the H. So H equal to B minus A divided by N, and then the H equal to 17.25. So the next step we have to calculate for the FXI, and we have to fill in the table. So for the area of the pool A2, the lower one, we have 4,802.4 meters square. So the total of the area of pool is AP equal to A3 minus A2 and A1. So the total of area is 4551.884 meters square. And then we have to find the total tile used and the safe curtain and the curtain. So for the total tile, we find 1778 tiles, and the total curtain is 296 curtain. And for the extra, 10% safety of the each curtain is 326 curtain.
Okay, last but not least, we will talk about discussion. In this discussion, the problem state is to find the number of curtains by the engineer should buy to cover the surface of the pool by using Simpson's rule. In this project, the method of Simpson's rule 1/3 that we use to calculate the relative area. From the calculation, the area of upper part A1 is 5,825.7160 meters squared, and the area of the lower part is 4,802 meters squared. Okay, so I continue with the discussion. So the area of land and pool is 15,180 meters squared, and the calculated area of the pool is 4,551 meters squared. So since the size of the tile is 160 cm times 160 cm, we got about 1,778 tiles, and each curtain consists of 6 tiles. Taking a stroke of 10% precaution, the engineer shall buy 326 curtains to cover the surface of the swimming pool. Simpson's method is the most ancient and widely used method in solving numerical method in solving in civil engineering. That's all from me. Thank you.
Hi, my name is Putri Nur Emilia binti Muhammad Zamri. My metric number is CF210294. The number of carton the engineer should purchase to cover such an area can therefore be determined using Simpson rule. The Simpson rule is merely an approximation that can be used to estimate the calculation. As such, it does contain error, but those errors can also be measured. For equal data space, we have discovered that Simpson's 1/3 rule performs better than any other numerical method. The formula, phrases, and methodologies used to be addressed engineering-related problems that require calculation must be familiar to every engineer.